When we started with SOLIDWORKS in, I believe it was 2003, the software made the process go much more smoothly. The parametric design was a step above what the software that we were using before, and we were able to generate models, revise the models, generate two-dimensional drawings for our vendors all very quickly and with much more accuracy than we were able to do before. When we got our 3D scanner, that also sped up the development process as well. Before, we would have to have a car here for the entire duration, which could be a couple of weeks to develop a product. Now we could get a car in here, scan the area and the stock parts in one day, go back to our desk and do a lot of the development work on CAD without the car. When we are able to have a couple of prototypes grown, we would then get the car back and fit check and test the parts. So after we have 3D scan data, we would design a prototype exhaust using CAD. Once we have a design or several designs all ready to go in CAD, we would need to build a prototype to install in the car. And for that, we would use our 3D printer to print fixture pieces like this that would plug right into our fixture table. You can see a number of them here, and they define all the straight sections of pipe and where any of the mounting points are going to be on the car. Once these are laid out on the table, then our fabricators will be able to build a prototype using metal, welded together, fully functional. And once they're done, we know we'll have a piece that will fit into the car perfectly, and we can get going on road testing and doing sound checks and sound measurements and things like that.
At ALW, we make architectural lighting fixtures. We make fixtures for commercial applications, rings, linear lines of light, pyramids, all sorts of different shapes. Basically, lighting fixtures to help architects create beautiful spaces. We use SOLIDWORKS basically every day. It's absolutely critical to our design process. Every small idea, every quick sketch we have, we draw it up in SOLIDWORKS. SOLIDWORKS is great because we can come from rough concept to an idea we can share with the rest of the team very quickly. As we get a little bit more refined in our designs, we use SOLIDWORKS to develop the entire concept. We use it to design parts for extrusion, for sheet metal, for machining, for molding. We use it to control large, complex assemblies with many configurations. And basically, SOLIDWORKS helps us to keep all of that managed.
I'm Bob DeGudis, R&D Manager with Drake Automotive Group. Drake Automotive Group is an automotive aftermarket parts company specializing mostly in classic Mustang. We do also do off-road and late model muscle cars, Camaro, Mustang, Challenger. Drake was founded approximately 30 years ago by Scott Drake. First started with a piece of trunk weather stripping and has grown the business into roughly 9,000 SKUs. So back in the day, it was still hand drawings. We didn't have any CAD capabilities. There was no 3D printing capabilities. The technology that we have nowadays has definitely helped us bring products to market quicker. We have gone from an ARM that we had and early SOLIDWORKS to now a HandyScan 3D scanner. We also have a 3D printer so that we can rapid prototype our models. We really needed to find a technology that would give us a full 3D model of the parts that we were working on. We looked at several different technologies. We decided on the HandyScan because of its accuracy. We use the scanner not only for new product development but also for inspection, which is very important in our industry when we are trying to do concourse correct parts and they have to match exactly how they were made back in the early 60s. The HandyScan allowed us to get the detail of everything we needed, plus check against incoming parts against an original to make sure that we had an exact concourse replication. When we started to look for 3D scanners, we directly went to GoEngineer to see what they had to offer. We discussed multiple different options and finally decided on the HandyScan for a number of different reasons. One of them was portability. The vehicles that we're usually scanning on are in different areas of the country, different areas of the shop. It makes it very easy to use. We also were looking for the accuracy. For us to be able to inspect parts was a big selling feature for us. We wanted to be able to check incoming parts against original samples. After we've acquired the scan with the HandyScanner, we take the point cloud data into GeoMagic. GeoMagic we really like because we're able to take the point cloud data and get it into a SOLIDWORKS model much quicker than without it. This is very important for us when we're doing new product development. We may take a concourse part that we want to change slightly. We can take that into SOLIDWORKS with a full design tree and start our manipulation of the parts. The automotive aftermarket industry has changed quite a bit in the last few years. It's very, very competitive. The speed to market is something that is always being pushed upon us to bring products faster and faster to market. We couldn't do this without the gains in technology. The HandyScan, Stratasys 3D printer, SOLIDWORKS, and all the other tools that we have at our disposal is what gains us an advantage. Without these, we would fall behind quickly.
Hello, my name's Shane Wooldridge. My title is Principal Mechanical Engineer. I'm with ETS Lindgren. ETS Lindgren, we actually design radio frequency equipment and systems. These include the chambers, the antennas, and we offer our customers a complete solution. When I started here at ETS, we initially just had SOLIDWORKS on our main machines, and we would actually do the designs in the engineering department. We do the models, the assemblies, and the drawings, and then we would hand over and make copies of everything and give it to planning and manufacturing. Of course, that was a long, tedious process, and we were actually wasting a bunch of paper. So we had to evaluate and finding a new software package that could meet our needs. And I think most of our goals was to allow manufacturing to be able to view our drawings as well as our assemblies. Well, another thing we were looking at is actually how to improve and document our process as a whole. We wanted to make every facet of our design process be documented. When we received the vault, we had this idea of how we wanted to communicate. So the individuals at GoEngineer came in, we talked about it, we actually put it up on a board and we scribbled it out and did a workflow. And by the end of the day, we had a workflow that was actually continuing. So this is our workflow that we have here at ETS Lindgren. So initially the project manager gets a what's called an engineering project order. He initiates the EPO, and this is a special design or something like that the customer actually requires. From that standpoint, it goes to the VP of Engineering, and if the VP of Engineering is satisfied with all the specifications and all that good stuff, he forwards it to the Mechanical Engineering Manager, And then from that standpoint, he can either go from the engineering manager to the technical writing or the electrical engineer. Once that's determined, it goes to the mechanical engineering manager, and then goes to the mechanical engineer, and then the mechanical engineer will do his work in process. That's doing the drawings, doing the models, doing the assemblies, making sure everything fits, form, fit, and function. And then it goes into work in process, and so then we can also put it on hold if we want to, like we have to wait on a customer approval drawing or not. And once that's approved, then it can go back into work in process, and then once that's completed, it goes into manufacturing and it goes into completed state. And that's really our process.
Peterson's has been here since '61, founded in a little garage by quite a handy gentleman, and his son come in years ago, starting off working repairing farming equipment and everything else, and it grew into that to aerospace work, actually working on one of the original moon landers. We now serve, I would say, everything from the shipping industry on the East Coast, power generation, nuclear waste handling, nuclear fuel generation, weapons development with some of our local suppliers for our military, amusement rides, and everybody is always liking that. There's nothing we can't do or handle any given time. We have approximately 200 projects going on here. Anything from something you can hold in your hand to build to 200 ton plus. We've implemented PDM in the past few years for our document and data management, and it is far and above what the old work groups PDM was. Friendlier, more robust. We're working at remote locations. We've got 2 facilities. We can have multiple people working on the same project, sub-assemblies and everything else, doing our configuration, management, version, and revision management. That's been a huge plus to us. The fact that SOLIDWORKS is so user-friendly and the PDM data management is user-friendly has allowed us a lot of latitude with regards to controlling our quality documents, our inspection. We're even putting our procedures in there, contracts and what have you, because we can control those as well in a single spot, single source data. It's eliminated a number of issues we'd normally have on the floor with regards to building to possibly incorrect revisions. This way we know we're always getting the latest versions.
My name is Ken Campbell, and work here at Peterson Incorporated as the IT manager. One of the things that has helped us a lot is the ability for us to change the workflows fairly easy. Adding users to the groups and administering it that way has been fairly simplistic. When there is a change that needs to be done, it's fairly rapid that we can get on that and take care of it for the end user.
Prior to our implementation of SOLIDWORKS PDM, we did not have a good way, an efficient way of managing parametric CAD files. Just single files that had no external links was reasonably easy to deal with in a regular Windows or DOS environment. The thing about it was, in order to actually do an efficient revision, we would have to copy an entire project from, say, one location to another, and then revise each and every individual assembly part drawing as needed. So now we've got duplicate file sets, which can be very confusing, let alone the network strain it would cause with all of these files on at any given time.
It's made things more efficient on the network as far as traffic loads and things like that, where it stores the files local. Security side of it's been pretty simplistic, especially with workflows. And setting those up, we got a couple of sysadmins that it was easy to train them. They've been able to kind of just run it without hardly any support.
We evaluated a number of document management systems, and there's some good ones out there. We went with SOLIDWORKS PDM because of the symbiotic nature it has with SOLIDWORKS itself. And it's just easy to use, simple as that. GoEngineer come up and did some training with us, help us set up our workflows that we instructed them on, which was a great way to go. Frankly, in that respect, we were probably our own worst enemy because we made it way too complicated in the beginning. Because the software under itself is a fantastic tool for controlling each and every one of the files. The nice thing is it'll even recognize the parametric relationship between other mechanical CAD packages. It's been a great tool to manage all the files that we have incoming from our customers. And again, we can revise our inspection plans, procedures, and go back to a single source data so that we don't have multiple files around. The GoEngineer boys have always been there when I needed them. They've helped us with understanding file translations, helped us with modeling issues across the board. Any kind of customized training they've put together for us at a drop in the hat, and that goes with our SOLIDWORKS and our SOLIDWORKS PDM. I can't say enough good about them.
My name is Sven Etzelsberger. I'm the Chief Technology Officer at URB-E. We are the leader in foldable electric vehicles. Our foldable electric vehicles are personal. They can go with you anywhere you want. They go into a bus, into a train, into your car. You can ride them around in the city. They are the perfect solution to do 1, 2, 3 miles in a city. I'm originally from the automotive industry. I used to work at Porsche in Germany and then later at the Porsche styling studio here in California. When that studio closed, I didn't want to leave the country and worked for a while at Ford and later at Fisker Karma. At Fisker Karma, I had my first encounter with electric vehicles and really the challenges of transportation. And one of the things I realized throughout my career is that it does not take a 3,000-pound vehicle to move a 180-pound body. There's a lot of energy that gets wasted in just moving the vehicle as opposed to the original purpose of moving a person. So we can achieve the same goal with a 30-pound vehicle and only use 1.2% of the energy that a car uses. The design of new products always starts with a sketch, an idea, a concept. Sometimes it's really just a napkin sketch. We take it from there, build the first model in SOLIDWORKS. It's typically a 2D model where we figure out the kinematics, make sure the basic function of the product is there. Then we go into a 3D model and do FEA simulation to make sure that the vehicle can actually carry the loads and can fulfill the function that we intended for it. After we are happy with the strengths and the FEA simulation, we then create first prototypes. We utilize the CNC capabilities of SOLIDWORKS to create cutter paths, feed our Haas CNC machine, and create the first prototypes. Since we started a new company and we had no constraints of any legacy system, we looked at the market and all the available systems from the lowest end system to the highest end systems. And we decided for the complexity of our product and the needs that we have on a CAD system, SOLIDWORKS is really the perfect solution. What attracted me to SOLIDWORKS is that it allows us to keep a lot of the auxiliary data all contained in a single assembly, really. We keep our FEA simulation, our part design, our drawings, our cam paths, our cutter paths, all in a single assembly, and that helps us to keep our data organized without too much effort. On our first generation URB-E, we used a lot of aluminum extrusions that had to be machined from all 4 sides to get the weight savings that we want for the URB-E. For the second generation, we changed that approach and went to a sheet metal design. So we start out with a flat piece of aluminum sheet, cut it on a laser cutter, and then fold it into the shape that we need. The sheet metal capabilities of SOLIDWORKS helped us a lot to get production costs down and ultimately offer a more affordable vehicle to our customers. GoEngineer, as a reseller of SOLIDWORKS, has been a really valuable partner for us. In our design process, we often have questions about the functionality of SOLIDWORKS. There's always something that can be learned, something that we don't know yet. And the support has been very valuable, it's available, it's knowledgeable, it's always there when we have a question to help us get further.